Good. Oh, Dilbert, already a great start. Yeah, awesome stuff. I'll disappear. Over to you, Zander.
Good morning, everyone. Apologize. I found the camera that was sitting under the table. It's about from 1990. So I'm sure you've heard a lot of talks about containers. This is a talk about Cloud Native Buildpacks, which is a way to make containers. I'm going to just introduce myself. My name's Zander Mackie. I work at VMware. I used to work at Pivotal. I came into VMware through the acquisition. For about 2 years I've been there, working on various aspects of the Cloud Foundry product. I've been an open source contributor for a while. And I had a lot of weird jobs before I was in software. I was a cheesemaker, et cetera. Feel free to ask me about those things on the Q&A at the end. That's a picture of someone named Zander Mackie, who's not me. That isn't a weird job I had, but that's a guy with a sturgeon. Funny picture for the morning. Okay, quick disclaimer. This is a really high-level introductory talk about Cloud Native Buildpacks. You don't necessarily need Docker experience to get something out of this talk, although having used Docker a little bit would be helpful. I'm going to show some demos that do use Docker, but no means required. This should be an invitation for you to dig more into the subject. I hope you feel like excited about it, like maybe it's something you want to explore, and I'm going to talk about some resources at the end to give you more. Okay, quick agenda. I'm going to just give us some vocabulary so we're on the same level set with respect to containers and particularly container images. I'm going to spend the bulk of the talk, no surprise, talking about Cloud Native Buildpacks. I'm going to give a quick little bit at the end about, really why you'd want to use them, to dive into the details of that, and then share some resources. Okay, so when people talk about containers, and I'm sort of assuming the audience here has heard of them, I'm going to just bring us down to the roots, which for me, containers always start with the container image. If a container is a process with a context, the container image is all about producing that context. It's almost like a little bento box. You go to the store, you get everything you need for your lunch. Here we have a container that has your app code, environment for your app, like configuration, whatever it might be. The container image might have operating system bits that your application requires, ImageMagick for parsing stuff and making security bugs. And of course, it will have dependencies of your application that are part of your code, like node modules. Every container image is full of node modules. And once you have one of these images, this is where the power of the container image comes. You can duplicate it. You can size it up. You can shrink it down based on the resource needs of the application or the requirements at the time. You can, copy it 1,000 different places in a lot of different environments. You can move it around. It's a portable artifact. And you get the same experience running it on your local computer as you would in the cloud potentially. Big caveat there, but that's kind of the goal that we're getting at. So when I say container image, you might say Docker image. Some people would say OCI container image. But just this is all about how do we build container images. Okay, so going back in history a little bit, we're not going to go as far back as this picture, but Buildpacks have a history that runs a little bit, sort of parallel, and then now it is intertwined with that of containers. Starting in 2011, Heroku, which is a platform as a service provider, they started using this term Buildpacks. It was potentially around before, but for them, it was a way of describing one of their secret sauces, which is take source code, turn it into something that can run on the platform super easily. Truth be told, is when I was learning to develop, I learned on Heroku. I did the Michael Hartle Rails tutorial, git push Heroku master, turn your Rails app into something that runs. And I didn't need to worry about, as a new developer, how I took that source code and it got turned into something that could run somewhere. Okay, so keeping that sort of platform as a service abstraction in your mind. 2013 comes along, Docker blows on the scene, democratizes the use of containers for developers. I think, the big innovation that Docker had, in addition to just turning on a container in your local machine really easy, was the Dockerfile. It was a way of portably moving around the artifact that your container was built out of. It was a way of describing the entire environment. Dockerfile let you build something on your local computer, send someone the Docker image, and then they could turn that same thing on in their environment. You also had Cloud Foundry in 2013. That's another PaaS, platform as a service provider, which has a history that continues along today. Cloud Foundry took the ideas that Heroku had come up with around Buildpacks and iterated on their own thing. They have a lot of different enterprise spin to it. They work offline, things like that. But they sort of came up with a parallel track of Buildpacking. And then in 2015, you had Kubernetes. Kubernetes becomes now, in 2020, in some ways the de facto standard for where containers run when you're running in production. It's a universal container platform. And so it makes sense to target that platform. It makes sense to target the container image if you're trying to do something like build a platform as a service like experience. 2018, the Cloud Native Buildpacks project was born. This is a CNCF chartered project. Folks at Spring, folks at Heroku, folks at Cloud Foundry came together and decided that they wanted to marry the best of the PaaS experience, the best of the really simple, take my source code, turn it into something that can run, and I don't really care about the details, to, with the best of container technology. So now Cloud Native Buildpacks were born. It's 2020. We've been working on the project a little while. We're incubating in the CNCF. We're working on that. And we're working on 1.0. Hopefully what we'll also get in 2020 is more people in the project. That's really the big goal of this year. Okay, so that's the history. The big picture of what I'm going to show you with how Cloud Native Buildpacks work is depicted here. Your source code up on the left is combined with Buildpacks by a platform, and then it runs and it turns into an application container image. This won't necessarily make sense right now, but I'm going to show you some demonstrations, and hopefully we'll dig into the details a little more. Okay, quick demo. Okay, I am going to show this. Okay, so this is a demo of Pack building a really simple Ruby app. The app has a gem file, and it has a simple route. It's a Sinatra route. It just, when you curl it at the root, it'll return hello world. Building this app into a container image is as simple as executing pack build and then giving it a name. Pack is a CLI that we maintain as part of the project. I'm just going to expand that. So you see that we downloaded Ruby and we got some Ruby gems going. And then in the end, we exported an image, sample app. So we're going to run that image. Okay, so I said you didn't really need Docker. This is a pretty basic, simple Docker invocation. It lets you turn the container on in your local computer to see. Okay, we're going to run it in the background. Curl it. Okay, we see hello world. Cool. So as is usual, the requirements change. Someone says, I don't want to say hello world. I want to say something else. I don't know. Let's modify it. Okay, so you need to rebuild your app. Very easy. Now it says hello everyone. Okay, cool. Well, we want to rebuild our container. How simple is that? Really going to be the same thing. Pack build my app. And there will be a couple of interesting things to note about this second run, which I'll talk you through. Okay, so that was a lot faster. Why? Well, we didn't have to download the gems. We were able to reuse them. We were able to reuse the Ruby layer. Really, all that we had to rebuild was the app layer, which is really all that changed, which is nice. Pack has sort of smart caching. It isn't just about the file identity. There's sort of business logic, if you will. The build packs themselves know about when they should be changing their cache. So we booted it up a second time, we curled it, and we see that we get the new app. Pretty simple. Okay, going back to the presentation. So what did we see? Oops. Okay, so what did we see? We did a pack build, we gave it a name, we ran it, did some modification, we rebuilt it, and we reran it. It's a pretty simple loop, but one you'd probably go through a lot as a developer, make modifications, rebuild the thing. And the niceties you get with smart caching show that, the second time you do something, well, it's going to be a lot faster. You're going to have a faster loop. So at a high level, we took our source code. This is the Cloud Native Buildpacks colors. We turned it into a container image in a pretty seamless way. You'll notice I didn't have to write any sort of file in that folder. There's no Docker file. There's nothing that describes the dependencies of the application anywhere. The build packs themselves detect all of that. So we got out of that an application image that's fully runnable, reproducible, deployable without me as a developer having to write a Docker file. Buildpacks did that magic for me. So let's talk a little bit about what happens when a build pack executes. Now, a build pack has two parts. One of the nice things we provide is something called detect, which makes it so that you don't necessarily have to know what build packs you want to use. Build packs have logic that says, yeah, I apply to this thing. And then they might be then used later for your build. There's two phases of build pack execution. There's the detect, and then there's the build. In detection, all build packs are potentially in contention, and they have logic to say, oh yeah, I know about package.json. I know how to do npm stuff. I should do my work. I know how to do Java stuff. I should do my work. At that point, the platform, which in this case is Pack, but there's a few other build pack platforms, will select the build packs that are going to be used for this particular build, and they'll do their work. They'll be executed one after the other. They'll download build and runtime dependencies, Ruby, Ruby gems. They'll compile node modules if they have native code. They'll, build your source code if it's a Go app, that sort of stuff. And the final thing they'll do is they'll set the launch command. The thing that when you Docker run the container, or the container image is annotated with the process name and the arguments that turn it on. Okay, so all of that's sort of magical, but peeling back the hood a little bit, one of the things that makes this work is a concept that we have called a stack. A stack is a collection of two things. It's a build time environment and it's a runtime environment. And those are really just images. They're containers that are spun up when we do build and run that are used as a context for your application. So when we did a pack build, we were running it on something called a builder image. Builder image is a collection of build packs with something called a lifecycle, which is a sort of the piece that is the heart of all of this, and the build image of a stack. Build packs are compatible with a particular stack. They then have a build context via the build image, and they might have things like GCC accessible during build that they wouldn't necessarily need during run. We have there's a stack called Slim. I think it's called Slim. Tiny. It's called Tiny, that has, some GCC in the Go compiler in the build image, and it has nothing in the run image. So you get really lightweight binaries. You can see this builders that are available. Pack as a command. Pack suggests builders. At this point, there's a few public builders available that are published by VMware and Heroku, and that is a community list. So as people start to make builders that are sort of broadly trusted, we're going to put those on the list. Okay, so that was sort of demo. We're going to talk through this big picture diagram again. Pack in this case is a platform. It's a Buildpack platform. It's a CLI in this case, but it happens to be a platform too for running Buildpacks. There's a few others. There's something called Kpack, which is a Buildpack platform that runs in a Kubernetes cluster that, given a pointer to source code and a set of Buildpacks, will basically always keep a Docker image up to date in a registry. It just monitors changes for all the inputs, and then when anything changes, it builds a new image. If the stack changes, if the build image changes, or the run image changes, Kpack will build a new version of that container image and make it available. So hopefully the high level makes a little more sense at this point. Okay. I'm going to do another demo, which is going to be live, and wish me luck on that one. Okay, I'm going to swap over to my terminal. Okay. So I showed a Ruby app. We have, in the Buildpacks project, we publish a repo called Samples that has a bunch of examples of all these pieces. There's like simple apps in there. We use it a lot for our work. There are examples of Buildpacks in here. The Ruby app that I showed is from here. One of the other nice things you have in here are examples of stacks, builder images, something called packages, which is a Buildpack that's published as a container image, so you can store them in registries, which is kind of cool. Okay, so back to the CLI, get it through all the usual sources, Homebrew, etc. It has, it has a lot of commands. I really only talked about pack build. A lot of the rest of this is for people that are sort of maintaining environments, like operators. The people that maintain Buildpacks use a lot of these to publish builders. Here's a list of the builders that we have at the moment, and they have information about them that says, what languages are available. There's Java, Node, Python, Golang. There's a pretty broad suite of languages that you could build right now. I'm going to, for the purposes of the rest of this demo, set the default builder to one of the sample builders. If I didn't necessarily set the default, I could run a command like this. Pack build, as we showed before, this is the name of the container image. I can tag it, so I can change my tag if I want. I can tell it what builder to use, like what build context do I want to use. I might know particular Buildpacks are available on one versus the other, and I want to use that. And in this case, I even really know what Buildpack I want to use, so I'm just going to try that one. But the first thing I did, I had the no pull flag. You could do this in an offline environment, an environment where you don't necessarily want things to change. Huh, I don't know what's going on with that. I don't know if my internet's being wonky or what. Well, hopefully the rest of these work. Okay. demos are always a risk, right? This invocation, I'm including this publish flag. And what publish does is it, rather than putting the image in your local Docker daemon, rather than storing it locally, it's actually going to store it. Oh, I already had a copy of that. It's actually going to store it remotely, which is pretty neat. It'll target any container registry and put the image there. And it will also be smart about reusing layers in a remote fashion. So if I rebuild this thing, the first time it told me, here's all the parts that went into building the container image. If I rebuild this thing, second time, you'll notice that it's reusing a lot of things. If you were to inspect the network traffic, you'd see that it isn't shipping new layers across the network to my registry. It doesn't have to do that. One of the other features that I'm showing sort of secretly is something called Project Toml. Project Toml is a way of basically defining a project. It's a pretty new feature in the Buildpack ecosystem, but it lets you say, I know the Buildpacks that apply to this particular application. I know certain files I want to include, certain files I want to exclude, give annotations about it. It makes it a little more ergonomic to sort of work with applications. Okay, so that was a quick high-level demo of some other stuff. So hopefully at this point you've seen that building simple apps is pretty easy with Pack. Question is, everyone's heard about Dockerfiles though. Why would you want to use this? And one of the ways we'd like to think about it is Pack is not a competitor necessarily to Dockerfiles. It's kind of a parallel experience. It might optimize different things. We're trying to optimize the experience for quick development. And we also, at the same time, optimize the operator experience. You can very easily control what can go into a Buildpack if you're operating an environment. I didn't really talk about that, but that is a whole story that we have. From a developer, learning to write a good Docker file is actually really hard. Docker publishes best practices. So when you're supposed to write a Docker file, you're supposed to create ephemeral containers. Okay, I don't really know exactly what that means, but I have to understand build context. Okay, so I'm trying to follow all these things. Multi-stage builds. Okay, I don't really know what that is. I just want to write my application. Okay, I don't want to install unnecessary packages, but how do I know if they're unnecessary? How am I supposed to decouple it? What about layers? What is even that? Eventually it gets a little ridiculous to try to do this well if all you want to do is just take your app and put it in the cloud. It's not really a concern that you as a developer would have. At this point, Docker is a pretty comfortable tool for some people, but not everyone wants to become an expert in Docker, and not everyone needs to become an expert in Docker. And that's kind of why we built this. Another thing about Docker is, SNCC is a security vendor. They make this claim that a lot of Docker images that are out there online that are even running in production have vulnerabilities at the operating system package level. It really could be as easy as rebuilding it if people knew about it, and a lot of it could be fixed by swapping the base image. One thing that Cloud Native Buildpacks can do, given the stack contract that I described, is really easily swap out the base image. So if a new version of the stack comes out, which there's an entire team dedicated to publishing a stream of those things, it's very easy for you to take an app image that you've built, swap out the run image that underlies your application source code, and just get a new version of it like that. It doesn't really take a rebuild. It's a simple operation. So stepping back a bit, as a developer, why would I look at Cloud Native Buildpacks? I think for me, it really comes down to the first bullet point, and everything else sort of falls out of that. The focus is on providing value for your end users as a developer. It's not like the way that you build application containers is not really, they don't care, and you might not even want to care. And Cloud Native Buildpacks are something that gives you the ability to do this quickly and easily, have other people care about the details of building container images and have that baked into the tools, and have it be very simple for you to get up and running. And there is a lot of complexity that you can unveil if you dig deeper. There is a lot of power, but initially, the experience of taking that Ruby source, turning it into a container image should be really simple. Buildpacks are also composable. That's a nice thing about them. Dockerfiles, you can compose them. It's a little hard. You can write from, do multi-stage builds right from Python. Use Python to compile some other thing that you might need as a prerequisite for Java, blah, blah, blah. But it becomes a little bit cumbersome. Buildpacks are built to be composable. You can chain them after one another, and they can give dependencies to each other. It's very easy, and it's pretty easy to control what ends up in the runtime of the run image. If you're a software vendor, Buildpacks are a nice way to distribute something like a runtime agent. It's very easy to just stick the runtime in a layer on the app image and call it a day. Furthermore, you can build, most any app with the same set of build packs. You don't need to customize them every time, because VMware and Heroku publish these suite of build packs that are broadly useful. You don't have to write a Docker file every time you want to build a new app. You can basically say, like, yeah, we trust these build packs, they work, and you don't have to think about that concern anymore. There's smart caching. The layer rebuilding is quick. Build packs themselves have logic about when they should be cached and not. They know things like, yeah, the file, the touch times are important, or yeah, the hash of the package file is important. It isn't just about the identity of the binary or the image, the thing going into the layer. And then rebasing is something that I didn't really demonstrate, but I alluded to. It's a nice thing that you can get, nice property you get when you use build packs. It makes it very easy to just take your app source code, put it on a new version of a base image. So resources to get more in, more out. We have buildpacks.io that has nice documentation and tutorials. We have a Slack. It's very welcoming and growing. A lot of contributors are there. A lot of users are there. On GitHub. The samples repo that I did a lot of these demos from is a great place to get started to play around. A pack CLI is available on GitHub. We also have a specification. That's kind of an interesting aspect of the project. It's spec'd out, and we have working groups Wednesdays and Thursdays where we talk about, we have an RFC process, and we talk about changes to the specification and RFCs in that working group. At the moment, it's publicly, it's technically public. We're not very we haven't figured out a great way of sharing it out without, having trolls jump in. But if you go to Slack and ask, anyone will be willing to invite you. We also have Twitter. So, yeah, that's it.
Superb stuff, Zander. Thank you very much. There's some great conversation going on the Slack as well. So I encourage you, if you've got some time after, to pop on and answer a few questions.
Totally.
We have got time for a couple of questions here. So Omar asks, Rails and other platforms often do a hot reload in the dev environment. How does this fit in with Buildpacks?
Yeah, I don't know. I actually haven't played with the Ruby Buildpacks too much. I would definitely encourage you to jump into the Slack and ask about that. The Buildpack Slack. Someone was asking about it the other day, and I think, you can't necessarily get the dev hot reload because when we build, we're spinning up a build container. We're working on part of the spec that actually would be like a develop workflow, where it would basically be like Buildpacks would define how to spin up a development container that then could be sort of an interim step. That's been discussed. It was in the spec, and we pulled it out because we hadn't implemented it, but it's definitely been a line of discussion for a long time. And if you go in that Slack and poke people, maybe you'll get your feature
Yeah, no, loving the inner dev loop stuff, and I think like the hot reload is a very interesting feature. So great to hear that you've considered that and looking at that in the spec. So yeah, I encourage Omar to jump in the Slack and have a look at that. So Phil asks, if I understood correctly, multiple build packs can apply to a single project. Does the order in which they run matter, and how is that determined?
The order does matter. Yeah, it does matter because the final build pack is the one that sets the start command. So if a Java app is the last one, it'll be sort of assumed that it's a Java app. You can modify that, like a feature just went in where you can like literally change the process that runs when you start the container. But yes, the order does matter in that sense. And other than that, the build packs that run before the final build pack are sort of known as like supply build packs. They can provide dependencies upstream, so they can say like, I provide a Python binary. If a Java agent needs Python, it can use it during build. It's available. They might do things like modify the environment, but then that's it. They might just add things to the path, but that's it. So the order does matter, and we sort of have a lot of smarts around automatic detection, but if you have a more complicated case, it's pretty easy for you to just say --s buildpack 1, --s buildpack 2, whatever, or use a project toml. That's really the simplest way to get a specific ordering of build packs.
Super stuff, Zander. Perfect on timing there. So thank you once again for joining us today, and we'll definitely thank you in the Slack too. I encourage everyone to pop along to Slack, chat to Zander there, and ask any questions we haven't covered here. We're going to take an hour